Are we at the edge of the next paradigm shift in software product development? Did AI already change everything? Is Agile dead? Or maybe long live Agile? For those and few other questions, I will try to find an answer in this episode of Pragmatic Talks. To better understand how the paradigm shift for software product development could look like in the nearest future, it would be good to take a look how it looked in the past a few times in the history of computer science and software development. Our history starts back then in the 1960s, where the first computers were built and the first computer programmers or software engineers were developing the first piece of code that was executed on these machines, on these huge computers that were fulfilling the whole buildings often. And at that time, the software development looked totally differently than it looks like now. Without diving into the details too much, I would like to focus on how the software development back then was limited by architecture of the actual computers. At that time, the most costly part of software development was actually not developing the code, but executing it on the computers. And computer time, execution time was limited. When engineers were developing new products, new software that was about to be executed somewhere at the computer, they needed to plan everything up front. They needed to foresee every possible scenario, every potential problem, and they need to write a code that will execute smoothly because the next chance for the execution may happen in the next couple of weeks, months, or even years. That limited the way people were thinking about the software development, about the product development. That actually caused the way how the software product development or software development were managed at the time, where people were trying to plan everything up front and execute the code only once to get some results.
3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
The things changed a lot in early 80s through late 80s and 90s, where personal computers appeared and many people started playing with them, started programming. Actually, at that moment, execution of the code wasn't as costly as it used to be. The main cost at this moment was developing the code, programming, creating something. The bottleneck of software product development was mainly distribution. At that time, when you wanted to give someone a program to run on their computer, game or app, at the beginning you had to send them a floppy disk, later on CD-ROM, and later on DVD-ROM. Many of you still remember how those things look like, but all of them are not used anymore, maybe in some legacy cases only. This limitation of software distribution also had some consequences in terms of how the software was built, how the software was programmed, and how the software was managed. Thanks to the popularization of the personal computers, we are able to build software for mass usage, for many users that were using the software on different computers in different ways, solving their day-to-day problems, day-to-day challenges. And that required better understanding of how users will use the software, and people who were developing the software needed to focus more on the preparation, on thinking over how other people, how users will use the software that they are designing and coding. This is why at that time analytics and software development analysis became so popular, and people were trying to prepare for every scenario, but not only every scenario how the code will run on the machine, but also every scenario how users could use the code, could use the program to solve their day-to-day challenges and address their problems that they want to solve through software. Limitation in distribution also caused that software engineers needed to focus on the quality. The software needed to be tested well. Software development processes were focused on quality assurance and quality control, where many software testers were involved in testing the software in a way the users would use it in the future, the way that they want to figure out if there is something that could go wrong or not. That was because in case anything would go wrong in this kind of software, then fixing it would require sending to all of the users a patch with the fixes, which obviously was pretty costly. The old software that was sold on the CDs and DVDs was hard to fix on production. And that limited the way how the software was developed and designed at that time. As a result, V and W software development models that you may be familiar with appeared on the market, and it was widely adopted in the software development companies. The next paradigm shift happened around mid-90s through early 2000, when the internet became available for the wider audience, and actually that changed everything again. Web apps became a new standard, and fixing a web app on a production was much easier than fixing a desktop app that was distributed on a CD or DVD in the past. In web apps, whenever you make a mistake in software, you can fix it almost immediately, put your fixes into the server, and your users will be happy with a new version of the software, and most of them wouldn't probably even notice that anything changes or if anything was broken in the past. Of course, it took some time for web apps to replace desktop application, and there were some time that in the middle that people were still focused on using this V and W models. That also created the opportunity for continuous software development methods such as Agile or Scrum, Kanban could exist, could be started and could be developed by its creators. At this moment, the biggest bottleneck for software development was actually coding. Because of that, people were focusing on figuring out how to code faster, how to improve the code, how to produce the code with the better quality so there will be less rework. And that results in creation of software development methods such as continuous delivery, test-driven development, behavior-driven development, or earlier domain-driven design, and few other things about the software architecture. Mid-2000 through 2010 and later was a decade of the wide adoption of Agile methodologies. I think that most of you already are familiar with Agile, with Scrum, Kanban, LESS framework, extreme programming, and many, many more. And that's because it was possible thanks to the internet, thanks to this continuous delivery. And that actually was the next paradigm shift where Agile became something that is currently widely used. If someone is not doing any kind of Agile method right now, it's actually pretty strange, even I would say so. This wide adoption of Agile and the previous changes in software development, increasing the speed of coding itself, caused the next shift where people who were building the software realized that at this moment, coding is not necessarily the most costly part, but actually coding the right thing is the problem that is worth to be addressed. That caused in the late 2010 the focus shift, the next paradigm shift, where people were starting focusing more on the product management, user experience, and actually talking to the users, talking to the customers, and working with them on addressing their special needs and special challenges that they have in their day-to-day work. Also, less became more. And product management at that moment wasn't focused anymore on addressing all of the needs of all of the users, but rather focusing on the minimal set of features that might be delivered to the production, delivered to the users, and validated pretty fast. So the feedback loop will be very short, and based on the feedback, developers or software programming team could focus more on satisfying more and more user needs in a short time to succeed and to surpass the competitions on the market. Focus on what to deliver was the next paradigm shift in that case. And here we are in the mid of 2020s, and a lot of things already changed. First of all, software could be delivered even 10 times faster than 10 years ago. I remember the time when we, 10 years ago, started working on some fintech app for one of our clients, and that required for us to hire around 20 engineers, managers, QAs, and other roles just to build a software that, after 1.5 years of development, was released to production and then improved incrementally a lot. Today, pretty similar software, pretty similar products, we are able to build in a couple of months with a team of up to 5 people and maybe one product manager, and that's all. So it means that we already speeded up the software development by 6 or 8 times or even 10 times depending on the software type. This type of speeding up was possible thanks to a few things. First of all, we have better tools than people had in the past. We have a better infrastructure, we have a better code repositories, and a lot of tools around code, a lot of infrastructure that are speeding up our work. Secondly, the technology advanced. All of the programming languages, frameworks, and infrastructure tools were designed to improve the coding speed. Thirdly, as I mentioned before, agile methods became a standard, and with wide adoption, people were using it better and better, so it brings better results. Next, there are new tools available on the market, such as low-code or no-code, that are allowing us to speed up the prototyping, building an MVP, or even building a production-ready systems using those tools. And last but not least, of course, AI. AI is speeding the work of software developers. We are also noticing it, pragmatic coders, how our work improved in the last 2 years since people in our team started using AI to support their coding efforts. So all of that makes me to think that we are already at the edge of the next great paradigm shift in software product development. Now we are able to build the software faster than ever before. We are able to collect all of the data about our users and how they use our application in the production. We not only can run A/B testing on the production, but also let AI to decide which version of the software to present to each user, and thanks to that we can build a product that will be hyper-personalized for every single user on the planet. And all of that together, as I mentioned before, is something that probably will lead to the change in how we develop the software and how we build the software products nowadays. What to expect next? Actually, nobody knows, but we can speculate on a few things. First of all, I believe and I already see that more and more code will be generated instead of just written down by the programmers. We will need less people in the software development teams. Teams are already smaller than they used to be. Because of that, some of these statements from Agile manifestos, such as individuals and interactions over processes and tools, may become obsolete pretty soon, because there will be not a team of the individuals working together on a product, but rather 1 or 2 individuals working together with AI on the software product. And then, like AI is a tool, so individuals and interactions over processes and tools, or maybe individuals and tools over processes. Who knows? Okay, we also have more data than we ever had before. Even today, direct communication with users in some cases could be already replaced by the analyzing of the usage data from production and using AI to actually help us make some sense of this data. AI already can predict users' behaviors pretty well. Check the Facebook algorithms or Google searches and Google ads. That's a great example of this kind of AI predictions for each users and AI personalization for each users on the planet. The work of UX specialists will need to be adjusted as well. It doesn't mean that they will not exist anymore or their work will not be needed, but they will need to both utilize the personal connection with the users, but also the data collection and using this data to actually predict users' behaviors and design the applications in a much better ways. At Tesla, AI is collecting all of the data about the production, about the systems, about the way people are working and what they are working on, and is making decisions every single second to optimize the budget reduction and optimize how people work and how efficient they are and what they should work on to improve the quality and improve the effectiveness of the entire company and Tesla itself as a product as well. I believe we are heading into a direction where users will not use as many applications as they are using right now. We will not browse through the internet in a way that we are using the internet right now. They will not be using websites or not so many websites, or they will not use the applications that we have right now. Sooner or later, they will start consulting AI to solve their problems in a way that they are doing this today with ChatGPT to just answer some basic questions. I think that pretty soon we'll see, or there are already a few solutions that will allow users to make some bank transfer over the internet just by telling about it to some AI models. And I believe that there will be more and more examples appearing on the market for this kind of AI or personalized AI agents, utilizations that will sooner or later replace most of the software that we are using every day. As you can see, there is more questions than answer. I think it's impossible to answer all of them today. The changes happening right now, and they are happening pretty fast. And that's not only AI, but the way the users are interacting with the machines, with the computers is changing right now. Try to think about it, what you could do to follow those changes instead of staying in the place where you are and be passed by everyone else who is moving forward with this trend. Please leave a comment and tell us what your thoughts are about the future and the great paradigm shift of software development. Thank you for watching this episode, and see you in the next episode of Pragmatic Talks.